Hey, so the topic of discussion is quicksort. So quicksort is a sorting algorithm for arrays, and it's a very efficient and very intuitive algorithm. It's efficient because it does not use any extra space, and it's intuitive because the logic behind this is very common. So the thing is, it could be understood by an example of students standing in a queue. So if they were to be arranged in a height ascending or height descending order, so if every student stands in the position such that the students ahead of them are all shorter than them and the students behind them are all taller than them. Doing the same for all the students would arrange them in a height ascending or a descending order. So that is the idea behind this algorithm. So how it goes is we start with the pivot. So the selection of pivot depends on multiple heuristics, but we can, for simplicity's sake, we can keep the first element as our pivot. So let's say in this array 10 stands as our pivot. We keep two pointers I and j, and we try to find an element such that moving I from 0 to n minus 1 and j from n minus 1 to 0, the first element which is greater than pivot. So the purpose of I is to find elements greater than pivot, and the purpose of j is to find elements less than pivot. So in this example, we can see that the first element greater than pivot I points to is 16, and here the first element less than pivot j points to is 3. So the idea is to swap them. So if these elements are swapped, the new array or the new formation of the array looks like 10, 3, 8, 12, 15, 6 and 16. Now the idea is to push I until we find the next element which is greater than the pivot. Again the same with j, the next element which is smaller than the pivot. Now we exchange this. We do this until the point when j crosses I. So until I is less than j, these elements are exchanged, and when j crosses I or I goes greater than j, we don't swap, and where the position where j stands, this is the position of the pivot in the sorted array. So if the element at the jth index is swapped with the pivot, so the new formation of the array looks like this. So we can see that every element here that comes before the pivot is less than the pivot, and every element that comes after the pivot is greater than the pivot. Doing this for all the elements would result in a sorted manner of the array. So the algorithm for this looks like this is the pseudocode. So let's say we take the first element as our pivot, and we start with I and j, the two pointers, from the start and end of the array. Now while I is less than j, we try to push the ith index till the to find element which is less than the pivot, and if we don't find any, we keep incrementing it until we find the first one. The same goes with j, and we check if I is lesser than j. If I happens to be less than j, we swap the elements and keep continuing until the point when I crosses j, like in this example. So that is when this loop will break and we enter this stage of the code. So at this place, we have actually found out the position of pivot where it will be located in the sorted array, just like this. And the formation of the array would be such that every element that is coming before has the value less than the pivot element, and every element coming after will have the value greater than the pivot element. So this is just the partitioning code that happens for every element. Now the quicksort uses this partition code to implement the sorting algorithm. What it says is we take two indices low and high, and this is a condition that ensures that the array is at least greater than two elements. So we find the partitioning index, and after finding the partitioning index, we try to implement the recursive call for the same quicksort algorithm for the elements that are like lesser than the pivot and elements greater than the pivot. So quicksort first, this algorithm first finds this, and then again implements the algorithm for the shorter arrays after this. So essentially, the final array that we get will be in a sorted order. The best case time complexity of this algorithm is order n log n, and the worst case is order n squared. This usually happens when the array is already sorted and we're trying to run this algorithm in this. Yeah, so that's it.